What's up everyone, welcome to the 24th tutorial in our Python Language Basics course. Here we'll take a look at an example of a class. By now we should be fairly familiar with what classes and objects are and how they can work together. Now we'll take a look at an example of implementing a custom class in the code. We're going to start by creating a custom class to represent some sort of object. I figure we'll use that previous example of the game character. That would be a really good place to start and will serve as a benchmark for the future tutorials as well. We'll add some fields. Again, those are going to represent the properties or the attributes or the state of the object. We'll add an initializer so that we can create instances. And finally, we'll add some methods for this particular class. So let's head on over to the code now. Right, here we are back in Google Colab. The last time we were here, we were covering tutorial 22. It was just parameters and return values. So we'll get started as per usual with a new cell. Now, the nicest thing about what we'll be covering here and in the next tutorial is that we've actually seen pretty much all of these concepts before, and now we're just kind of bringing them all together. For example, we know what variables are and how to use them. We know what methods are or functions and how to use them. And now we just need to kind of compile it all and put it together in this class-like structure. So because we'll be creating a player character class, the first thing we'll want to do is start by creating that. So we're going to use the class keyword to declare a new class, and we'll just call this something like player character. Okay, and actually we don't need the curly brackets. Okay, so a couple things. First, note that the naming is camel case this time, so we're not using this underscore notation, and we're capitalizing. So this is pretty typical naming convention. I guess you don't really have to follow it, but it's encouraged that you do. Second of all, again, we are dealing with the colon and indentation rather than the curly brackets, so just be aware of that. Now, one thing to note when we're creating classes in Python is that we generally don't, sometimes we do, but we don't usually declare the global variables up here. Now, in a lot of languages, we would declare some variable here, so variable 1, variable 2, variable 3, etc. Okay, and these will be all of the fields that belong to this particular class. Now, in Python, that's actually not the case. In fact, most of the variables we actually declare right in the constructor itself. Okay, so we're not going to see this kind of notation. We'll use a constructor to both declare and initialize the variables. So let's think about what properties a player character might have. There are lots. Realistically, if you're going to develop an actual game, there will be tons of properties, attributes, state, whatever, that you need to associate with a player character. However, we'll just kind of pick and choose a few. So we're going to go with something like maybe we'll have an X position. And don't worry, I will erase these in just a second. I just want to kind of type them out just for my own thoughts. So we might have an X position here. We might have a certain amount of health associated with this character. And also maybe we'll have a name. Okay, so we'll just stick with these three attributes for now. So again, just having these as reference, actually I'll shift them up to the top and we'll just comment them out. Okay. So now that we know the attributes that we're setting, we're going to use our constructor to set these up. Now the constructor, being a function, will start with a def keyword. Again, def is going to be used to define any kind of function. The initializer, or the constructor, I guess we should probably use a correct terminology. Initializer is more commonly used in Python, although constructor is pretty much interchangeable. The initializer is a special function, and so it has some special syntax. It's called init like this, but we have to surround it with these double underscores. So this is 2 underscores here, okay? And then we open up the brackets, and after that we can treat it almost like a regular function. So it's going to have to take in one additional parameter, as will every other method that we implement in player character, unless we're dealing with static methods, but more on that later. Okay, so for now, any method that belongs to a class, in this case player character, will have to have this parameter in it. Okay, it can have additional parameters. In this case, we would take in an initial X position, initial health, and an initial name. I think we'll do name first, then X position, and then we'll do health, like this, though the order doesn't matter too much. I'll explain this in just a second. Just bear with me here. We're going to take in these values, and then we're going to set them up like this. We're going to say self.name is equal to name, self.xposition is equal to xposition, and self.health is equal to health. Okay, so I know this was a lot all at once, but let's just kind of break down what's going on here line by line. So we're creating our initializer function. Again, don't worry too much about why we're doing this syntax, but we do need this particular syntax for the initializer specifically. Okay, again, initializer constructor are going to be the same. We are using the self here, as we will with any other method that belongs to our player character, just to say that this does belong to the current class. Okay, so this is what's called an instance method. We are taking in a name, an exposition, and health, and these are just some parameters, just like we would in any other function. Here we're setting the initial values of name, exposition, and health based on these, and we're using the self keyword again to say that we're setting the current class's name, the current class's exposition, and the current class's health. Okay, we may come across the case where we're dealing with multiple other classes within a class. For example, if we had an inventory of items, an item might be its own class. Well, an item might have a name, and for that you would do the item.name. Here we're saying that we're dealing with our name here, the name that belongs to self or the current class, and so that's why we're assigning this. Anytime we're accessing anything that's related to the current working class, it's better practice to put self. Okay, then in future methods, let's say I had something else, okay, and I wanted to access my health. In that case, I would say self.health. Okay, and this just makes sure that this knows that this is the current health that belongs to this particular class. Okay, so that's what that's all about. Otherwise, we're essentially just setting the variable values here. Like I said, in lots of other languages, you would actually have the variable name and then the type, so something like int or whatever, but that's not necessary in Python. We can actually just declare and initialize them in our constructor. So that is a basic class setup with just a few variables, but we want a bit more. We want at least one method or two. I figure what we'll do is we'll just have a movement method. Okay, so we'll do a def again, and this time we're going to call this move. Note how I didn't need the underscores. Okay, it's not necessary here because this is not necessarily a special function. Okay, but because it's a method, an instance method specifically, we'll need self again. Okay, so we're going to add this to all of the methods that belong to this class. We'll also do like we did before with a by amount. Okay, and then we'll just say self.exposition plus equals by amount. All right, so if you remember in the previous example, we had this slightly more complex move function where we basically couldn't go past the start or end positions, okay? And also we were actually returning the x position. Well, that's no longer necessary with our move function here. First of all, we don't necessarily know whether or not this player character can go out of bounds. It may be the case that they can. I'm thinking of a game like maybe Mario or something like that. The non-player characters can actually go off screen. Okay, so in that particular case, there's going to be no need for kind of bounds checking there. The other thing is that there's no need to return x position, okay, like this, because we're storing the new value of x position inside of this inside of the object that will be created by this player character class. So when we return the x position before, it was so that we could store it back into another variable and use that later on, okay? And that way we didn't have to use the global keyword. Well, with here, when we create an instance of player character and we call upon the move function, we're going to be storing the value of x position back into that object anyway, so there's going to be no need to return it in this particular case. Now, just to make things a bit more interesting, I figured we might as well add in another method or two, because we have this health variable and we're not really doing anything with it. The name realistically, once assigned, shouldn't change, so we'll just leave it alone. But let's say we want a function that will help us to take some damage, okay? That might seem weird to you that we're doing that rather than, let's say, an attack function, but it actually makes a bit more sense to have a function that will help us to take some damage, because that function will actually modify the current player character's health, whereas attacking doesn't necessarily modify the health. Okay, most of these methods are going to be used to modify the state in some way. For example, this is modifying the x position. These are definitely modifying the name, x position, health because it's setting them, and this one is going to be used to modify our health. So we'll call this something like take damage. Okay, and it's going to be self again, and then there'll be by amount. You know what, by amount doesn't really make sense, so let's say amount. Okay, or you know what, yeah, let's say amount, that should be fine. So then we're going to say something like health minus equals amount. Okay, so we're basically subtracting the amount from health, Okay, and if that health is going to be less than or equal to 0, or rather if it's less than 0, let's just set it to 0. So we'll say if health is less than 0, we'll just say health equals 0. Okay, and actually we made a mistake here. We should put self in front of these because we're accessing the current value of health that belongs to this particular class. Note again that we did self here because we're going to do that with all methods. Now, along with this, we'll just have a simple function to check to see if we're dead. Now, I know that, again, might seem fairly morbid to you, but realistically, a lot of games are centered around defeating or killing various things within the game. So this is going to be something that if you want to build a game, you'll probably have to implement anyway. So let's go ahead and do that. So we're going to do something like check is dead. Okay, again, self. It's not going to need any other parameters, but we will actually return true or false. So we're going to do a quick hack here. Well, I'm not sure I'd call it a hack necessarily. It's just short form notation. We're going to say something like return self.health less than or equal to 0. Okay. So basically, this will return true here if the health is less than or equal to 0. So if that is true, we are at 0 health or we're less. Realistically, we should never be less, but that's fine. Then we're just going to actually return true so that this function, check if dead, it will return true. On the other hand, if the health is greater than 0, if it's 1 or it's any other value than 0, as long as it's positive, then it's going to return false because this will be false, and so this whole thing will just return false. Okay, so fairly straightforward. Now, actually, let me just zoom out a bit. That's kind of hard to see the whole thing. So this is pretty much that's pretty much all we need to do here, actually. We've created a fairly simple class. We've called it player character. We've set it up with a name, an X position, and a health. Okay, we're not really doing anything with the name, but that's fine. We are going to be able to move around, okay, by increasing or decreasing the X position by some amount. We can take damage by modifying the value of this player character's health. Okay, and then we can check to see if this player character is dead by just accessing the value of health and comparing it to 0. So we'll go ahead and run this cell. It's not really going to do anything as long as there are no errors. That's really the only reason I'm running this. Okay, and the reason nothing happens is because, again, this is a little bit like declaring or implementing a class, rather. It's a little bit like that, but not actually running it. Remember, when we implement a class but don't run it, the compiler just checks it through to make sure the code is okay. As long as it is, then nothing else happens because we're not actually running any code. Okay? We'll show you how to do that in the next section, where we'll start creating some objects of this type player character, and then we're going to, from there, we're going to be calling on some of these methods to execute some behaviors and checking up on the values and stuff like that. Okay? So stay tuned for that. Thanks for watching. We'll see you guys in the next one.